Hello, everyone, and welcome back again to a new week and a new lecture. I know that the lectures can seem a bit redundant and overwhelming, but my promise to you is that we're just laying the foundational work for the start of the year. And as the year progresses, we will be more project based and not so much Miss Russell lecturing at you, okay? But having said that, today's lecture is probably the most important, one of the most, if not the most important lectures you'll have all year, because we really talk about the fundamentals and the basics of how to work a DSLR camera. Many people don't know what a DSLR camera is. Essentially, what it is not your cell phone, right? Not a little tiny point and shoot. It's a camera that you can set manual settings on, right? Meaning you can set the shutter speed, the aperture, the ISO. You can determine how much light enters the camera and therefore what type of image is captured. Okay, so I like to start this lecture every single year with these three images together, and I always pose the question to my students: what if I told you? Well, let me back up. I always pose the question to my students: how do you think this image was captured? Okay, so I want you to look at these three images, and I want you to think in your head: how do you think each image was captured? And these are how the answers usually go. Hands will be raised and students will answer, and they'll say, well, in the first photo, the pinwheel, which is what this is called, in the first photo, the pinwheel is not spinning. In the second photo, it is spinning. And then in the third photo, it's spinning really, really fast. So that's usually the answer that I get from students. Um, and then I revisit the question and I say, okay, well, what if I told you that in every single photo, the pinwheel is spinning at the exact same speed? Because it is. In every single photo, the pinwheel is spinning at the same speed. And then I ask the question again, okay, so now how do you think this image was captured? And then sometimes if I have students that have like a little bit of photography knowledge, a hand will be raised and they'll give me the answer, it's shutter speed. And I say, yes, it's shutter speed, you're right. But then most of my class, 99% of them are like, what the heck is this person talking about? What's shutter speed? And that's where today's lecture comes in. We're going to learn about things like shutter speed, aperture, ISO, and how we can capture specific images based on those settings on our camera. So these photos were caught using different shutter speeds, right? So in the first photo, we have a fast shutter speed, and so our subject was frozen in motion. So even though it's really spinning, the action was stopped because of a fast shutter speed. And then as the photo progresses into the middle, the shutter speed slows down a little bit, so you get the motion blur. That's what that's called, like the streak of motion. That's called motion blur. So we have a little bit of that motion blur captured in photo 2. And then in photo 3, it's a really slow shutter speed. So now we can't even really see the individual colors of the pinwheel. It all just like blends together, okay? So the blur of our photograph, blur based on movement, is captured based on what shutter speed we use on our camera. And if that still feels a little confusing, don't worry. You're not expected to understand that quite yet. We're going to get more into detail in just a little bit. So as I said, today our lecture is on the camera basics. Like, what are the basic functions of our camera? And we're going to answer that question fully. So we're going to start with how photos are created. And the most basic answer of that for that is with light. Without light, photography doesn't exist, right? If you ever try and take a photo in a dark room where it's pitch black, what's your photo going to look like? It's going to look pitch black. You're going to have no detail. And so in order to get that detail, in order to capture an image, we need light. And light is the number one factor that helps determine how we capture our images. Basically, how much light we allow to enter our camera creates different types of outcomes, and we're going to discuss that fully. So if you become familiar with all of these settings and with how light affects our photos, you can quickly go from like, I know nothing about photography, to like a pretty strong amateur, right? A pretty strong amateur photographer. And then eventually some of you might someday be more in the professional realm. I do have some former photo students who started out with zero knowledge, but now are making money taking photos. So you can go from knowing nothing to really being an expert on photography if you learn how to embrace and utilize the light in your photos. Okay, so let's talk about exposure. Sorry. Okay, so exposure is the broad theme that goes across all of the different attributes that we're going to talk about today. Okay, so all of the camera settings and all of that stuff that we're going to talk about today, the way that they work and the way that you do your settings is what creates your exposure. And exposure is the amount of light that you allow to enter your camera and hit the image sensor. Okay, the image sensor is inside of your camera and it determines how much light is coming into the camera. Okay, so how much light you allow, and an easier way to put that is how much light is coming into your camera. That's the exposure. Okay, too much light is going to give you an overexposed photo. So if we look at kind of the spectrum of photographs down here, we see that the far right side of the photo is almost white. Like it's way too bright. It's blown out. We lose a lot of the details. It's just like you look at that and you're like, oh, that's off. That's called being overexposed, meaning we have too much light coming into the camera and then it makes our photos too bright. Okay. You may have gotten that type of photo on your own camera, right? That's called an overexposed photo. On the opposite end of the spectrum, if not enough light, we look over at the left-hand side of that photograph. If we don't have enough light, that's called being underexposed. The photo looks kind of muddy. Again, you can't see a lot of the detail. It's too dark, okay? So the goal is to get right in the middle, to get to that correct exposure, okay? So how do we determine what our exposure is? Now, typically, and my students that are coming onto campus every single day, they've been shooting on auto, right? They just set their dial to auto and they let the camera do all the work. But eventually, and once we all come back to campus, the goal is to learn how to do all the settings on our cameras manually so that we, not the camera, but we are determining how much light comes into the camera, okay? And there are 3 ways to determine how much light comes into our camera. The first is shutter speed. And we talked about that with the very first photo that I showed you, okay? So shutter speed is one of the ways that we determine how much light comes into our camera. The second setting that determines how much light comes into our camera is called aperture. And then the third setting that controls how much light comes into our camera is called ISO, all right? So these 3 settings work together to create our exposure. And all of them help determine how much light we allow into our camera, okay? So let's start with the first one. Let's talk about shutter speed. Now, shutter speed is the length of time that a camera, that the shutter is left open while taking a photo. And I'm going to pause this right here because I should have had a camera with me. This I can explain it better. So I'm going to run back to my office and grab a camera and I will be right back. Okay, I'm back with one of our classroom cameras, camera number 17. Shout out to anyone who has camera number 17. Thanks for letting me borrow your camera today. But shutter speed is the length of time that a camera shutter is open. Okay, so if I were to take the lens off of my camera, and I were to look inside of my camera and look inside of the lens, I would see a shutter in there that basically is a little, and it's hard for you all to see, but it is a little window inside the camera. Do you all see that? Okay, so that you can see the light through it, right? And that is called the shutter, right? And that determines how much light is allowed to enter into the camera. Now, that shutter can stay open for a little bit of time or a lot of time, okay? We call this the shutter speed, and it's measured in seconds, but most often it's measured in fractions of seconds, okay? And so the bigger the denominator, the faster the shutter speed. So if you guys look at the examples that I have on there, if we have a shutter speed of 1/1000th of a second, because remember, shutter speeds are most often measured in fractions of seconds and not full seconds, because a shutter speed of 1 second or longer is a really, really slow shutter speed and you're going to get blurry photos, okay? But 1/1000th of a second, that's a fast shutter speed. It opens and closes in 1/1000th of a second. So your camera is not letting light in for very long, right? Whereas a shutter speed of 1/60th, because the denominator is smaller, we know that that is a slower shutter speed. So it's staying open longer with 1/60th of a second, and it's opening and closing faster with 1/1000th of a second, okay? Now, you hear me talk about fast and talk about slow shutter speeds. Okay, well, what does that matter, right? So fast shutter speeds, like think back to our last slide, 1/1000th of a second. And in fact, your cameras go way faster than that. They go, hopefully you all can, let me get this to the camera a little better, right here. It's hard to do this backwards. Okay, so you can see on your cameras in class, and if you're not coming to campus, it will eventually be your camera when you come back to campus, hopefully. You can see on here that this shutter speed goes as fast as 1/4000th of a second. It's really fast. So that type of shutter speed can freeze a subject in motion. You have zero blur. Think back to our pinwheel, right? The photo way over here on the left, the action was frozen. So you have zero blur, okay? That's a sharp, fast shutter speed, what we call a stop action photo, okay? So the subject is frozen in near perfect focus. Whereas if we have, and I want you to hear that actually, okay? So I have this set to 1/4000th of a second, okay, and I'm gonna take a photo. If I took off my lens cap. Okay, I want everyone to listen. Hopefully you can hear it. Did you guys hear that? Not really, because it was one long sound. You didn't hear your shutter open and close. I'm gonna do it again. It was so fast that it was like, I'm like, I didn't hear anything. So let me give a slow shutter speed. Let's go down to 5 seconds, okay? So let me show you again. This is a shutter speed of, man, it is hard to do this backwards. Put this on the camera. Shutter speed of 5 seconds, okay? Why does this feel so awkward? Okay, so listen now. Hopefully you can hear this. Did you hear it open? Still open. And then it closed, okay? So that shutter stayed open for 5 seconds. And I guarantee you, if I were to look at that photo, I would show it to you, but it's actually just white because it was very overexposed. But if I had it at the correct exposure and then I took a 5-second exposure with a shutter speed of 5 seconds, that image would have been very blurry because it would have allowed a lot of motion to be recorded, okay? So what's the outcome of a slow shutter speed? That one I just showed you, like a 5-second shutter speed. It captures a subject as it moves through the frame. So if I have someone that's like jumping up and down for 5 seconds and I take a photo of them with a 5-second shutter speed, it's going to capture every single motion that happened in that 5 seconds. So what do you think the outcome is going to be? Well, the outcome is that the subject is typically blurred, right? So again, think back to our pinwheel. Okay, so how many times do you think that pinwheel was able to spin around in the photograph on the far right-hand side? Right? It was probably able to spin around a couple of seconds. Maybe that was a 2-second exposure. And in those 2 seconds, that pinwheel was able to spin a few times. And so what did it record? It recorded this blurry pinwheel spinning around, right? Now, this isn't always a bad thing. Just because you say a photo is blurry because you allowed it to have a long shutter speed, the outcome can actually be beautiful, okay? So let me show you some examples of that. So this is a photo in which a slow shutter speed was used, right? You can see that the streaks, those are actually stars in the sky. This is a really popular type of photography. It's called light trail photography, and photographers will set their cameras up in the desert and they will take really, really long exposures, and then they will kind of compile or like stack all those photos on top of each other, and then the outcome is these streaks of stars, because the shutter was able to stay open long enough that the star, the streak of the star as the Earth turned was recorded. Okay, so let's see a few other examples. Here's another slow shutter speed. The shutter stayed open long enough so as the water came down the stream, it recorded the motion of the stream, and it kind of creates this real dreamy, like beautiful blurred effect, right? Okay, I'm going to go through some of these, a couple more. So you can see the difference between fast versus slow shutter speeds in this photograph. The photograph on the left, you can see that we had a longer shutter speed, right? So the motion of the water was recorded, and it leaves behind this kind of fuzzy like trail of water. Whereas the photo on the right, it stopped the action in motion, and so we see individual droplets, okay? So I'm going to stop there. We're going to pick up on shutter speed, review it a little bit tomorrow, and then we'll get into aperture. All right. Bye, guys.